Yo, how's it going? I have it a little bit purple in the background. I have the stirred classes. Now we are ready to vibe. Positive vibes only tonight. They are very reflective, so I don't think I will wear them on stream. Okay, so this is the video from this week. It's another episode in the sudo series. It's episode 6. It's basically the crash root cause analysis of the crash we found last time. Last video was about minimizing a crash case that we found through fuzzing it with AFL. So now that we have a minimized test case and we can easily, reproduce a crash in sudo, now is the question, where does the overflow actually happen? Because this is very important knowledge, or is probably important knowledge if you want to write an exploit for sudo. So the reason for that is that when you corrupt memory, corrupting memory doesn't cause a crash immediately. Corrupting memory just means you mess up stuff in memory, and when other parts of the program try to act on this corrupted memory, then it could cause a crash because it did not expect these values to change. For example, if you have pointers, if you now overwrite them, then when a piece of code wants to use this pointer, then it causes a crash. Except obviously you carefully control this pointer, then maybe you could achieve more. You could maybe turn it into a arbitrary code execution. But to be able to better understand these crashes, we need to figure out where exactly is the overflow caused. Because right now we only have visibility into the symptoms of the overflow where it crashes later, and we don't know yet where exactly the overflow happens. And this is where AddressSanitizer helps us, and this is what this video is about. It's basically telling you how I tried to use ASan to analyze the crash that we found. Through fuzzing sudo with AFL, we have found a crash that looks very similar to the known sudo edit vulnerability. However, that crash is actually an abort because the heap seems to be corrupted. And this abort is just a symptom of a memory corruption that must have happened earlier in the program execution. And now we want to find exactly when the heap overflow happened. We want to find the actual root cause of this vulnerability. And there is an awesome analysis tool that everybody who works with C code should know. It's extremely helpful for debugging any kind of bugs, not only security bugs. But we use it because we want to learn more about this crash. And this tool is actually a compiler feature called AddressSanitizer. So let's create an ASan build of sudo to find the root cause of the memory corruption. From the fuzzing project, we can find a few tips to find bugs with compiler features, and it tells us about C flags like AddressSanitizer, fsanitize address. So let's add this to the build configuration from sudo. And because we are not fuzzing anymore with AFL, we can just use regular clang instead of AFL clang. So basically what we are doing here, you have to a little bit understand how C programs are compiled and the interplay between configure and then make, which then invokes actually compilers and whatever. And this is just like what's it called? It's just like a standardized way how people do it. You could create your own build system. It doesn't have to be this way, but typically configure. You can specify the C flags, the compiler flags, which are then later passed to the compiler. So you can add here additional, command line arguments that you want to be later used by the compiler. And in this case, we want to pass the fsanitize address, argument to the compiler. That's why we set the C flags. And as I said here, we are using now regular clang because we are not fuzzing anymore. In previous episodes, we used AFL clang, which instruments the resulting binary to be fuzzed with sudo. It's adding a lot of stuff, for AFL to gather information about the fuzzing stuff. But now we are using regular clang. So we just want to create basically regular sudo, but with AddressSanitizer enabled. And that's why we just call configure to change the build configuration for sudo to switch back now to regular Clang and enable sanitizer with the with this argument. Then let's build sudo with make, and in the outputs you should see the usage of fsanitize address flag. This means it should work. Okay, so you can already see I start running here into some issues. Crap, build failed, linker command failed. But I think I forgot to set the LD flags for the build configuration. So let's run. Yeah, so this is just stuff I just figured. Okay, I thought if you see here errors, I didn't mention this in the video, but you see here errors about undefined references to ASan related things. And this happens in the loader. So I figured, oh, maybe the loader needs these parameters as well. I'm actually not that experienced with all this build stuff. I just know that these are compiler flags. And so I just figured, okay, maybe if we tell the loader as well that we are using AddressSanitizer, then maybe it works. And that was the solution. Linker command failed. But I think I forgot to set the LD flags for the build configuration. So let's run configure again, followed by make. And that seems to have worked. If we execute the binary normally, we can see that ASan is working because we get this report that there are some memory leaks. But memory leaks are not important for security. By the way, so this AddressSanitizer flag for the compiler added now this address sanitization report when you execute the binary. So the binary just runs normally, but it's gathering ASan internally does stuff, gather information about memory things. For example, it tracks when things were allocated and freed again and so forth. And in this case, it noticed memory leaks. Memory leaks might be important for you to, in generally to avoid bugs, because you don't want memory leaks because your program could use more and more RAM, and eventually it would get terminated by the operating system because you use too much. So, it's nice that AddressSanitizer can show that. But for us, it's actually, that is not important. Like, we don't really care that the program uses maybe RAM that it didn't, or, use memory that it didn't clean up. Especially for a program like sudo, in principle, it doesn't even matter anyway, because it's like not a continuously running daemon or something. But we want to use ASan to detect overflows. And so we don't care about this output, and we can also disable it. We can also disable the memory leak reporting as well. Now we have a nice output. So let's pipe in our malicious input and let sudo crash with ASan. Wait, it didn't crash? See the normal output here and then the unimportant memory leaks again? Wait, what? So this was totally unexpected, right? From previous videos, if you have followed along, you know that we instrumented sudo in a way where we, instead of specifying command line arguments, we use an input file which basically contains the arguments, and this input file is then turned into fake arguments. Watched earlier episodes, we did this in order to fuzz sudo, and we still have this instrumentation, this wrapper in sudo here. So this is just something we have been doing the whole time. We always take our crash file example and then we pipe it into sudo, and then it would, use that as arguments. And these arguments should crash sudo. They did crash sudo just last episode. So why does it suddenly not crash sudo anymore? It should have already crashed. It should have not even gotten to this password entry. Seeing this, I already knew, okay, it doesn't crash anymore. Why does this input not crash anymore? This started to be an issue that cost me like 10 hours or even more. I don't remember. This was so annoying. See the normal output here and then the unimportant memory leaks again? Wait, what? I'm going to run here into a really annoying problem. This killed a lot of hours, and I decided to leave it in just to show you how I was troubleshooting the issue. Projects like this are never smooth. There are a lot of issues you run into. Throwing the input at the normal compiled sudo via our So here I just shared some thoughts I had at the time. We will soon figure out what the problem was, but for now I didn't know what was happening. I always compiled sudo, with configure and make, and then I would just pipe in the crashing input, which turns, this input into arguments, and those arguments are the crashing condition for sudo. So it would always crash. Why did it not crash? And here you can see the other example. Here I'm using AFL to sudo, which is a small wrapper that we wrote. It still crashes sudo. So this crash input should work. So why does it not work on sudo compiled with AddressSanitizer? That was driving me insane. If you see soon the solution, it's so dumb why this error happened. But for now, I was stuck. I was circling in circles because I could not understand what is different with the ASan build than to the previous sudo build. Wrapper still works. So what the heck is going on? Well, there's a bit of an issue with this stuff like this. Recompilation, especially with massive changes like the AFL instrumentation or now AddressSanitizer, can move around the code in the binary and thus create a slightly different environment where the malicious input just doesn't cause a crash. So these are some thoughts I had. So I tried to explain to myself, make up a theory that we then can, test with basically a scientific method. We make up a theory of our we have certain observations, and now I try to make up a theory that could explain this observation I have, and then we can also check these theories with other experiments to verify if they are correct or not. So I'm seeing here that ASan build doesn't crash and the AFL build previously does crash. What is the difference? Well, we did change a lot of compiler things here. The ASan instrumentation is obviously completely different from the AFL instrumentation. And so maybe this moved stuff around. It influenced maybe how things on the heap are allocated. And suddenly the overflow might still happen, but maybe now it doesn't lead to a crashing condition anymore. I don't know, like maybe it just changed stuff. This was at least a theory I had, but this probably also doesn't make much sense. It could also be that it only crashed because of some AFL stuff again. So something with the ASan build just seems to have changed. It's weird though, because ASan builds are usually a lot more fickle. It should immediately report an overflow case, and so it's kind of weird that it doesn't do that here. So yeah, this is what I'm saying here. It doesn't make really much sense because let's say if you have this theory that this recompilation changed how things are maybe allocated on the heap because, I don't know, there's an optimization happening, how large, I don't know, alignment differences or something, I don't know. So now the heap is differently allocated, and now your input doesn't cause an overflow of an object anymore that would lead to a crash. It just overwrote something unimportant. That is okay, but ASan usually should catch any overflow. It should immediately catch overflows. It should not, it's not like with AFL where we only recognize crashes if something crashes. ASan is a tool that is used to find the root cause. So ASan should report overflows even if it doesn't lead to a crash. That's why ASan is so cool, because you can maybe introduce overflow issues that never or rarely crash. That's why you never notice the bug. That's why these overflows might be, stay in the code base because you never notice them, because in most cases it never leads to a crash until a hacker analyzed it well and figured out a way to cause it to crash and then craft input that does something interesting. But what I'm saying is that ASan should immediately report on the overflow, so something else is wrong. It cannot be the recompilation. Something else must have changed with the ASan build. But I could not explain what is different. I just don't understand. So where do we go from here? I guess we could maybe try the original crash, not the minimized one. Or we can increase the override and the data, or generally modify the crash input a bit more. Yeah, so here you see me just playing around. So if the minimized test case doesn't work, maybe we just have to do a bigger overflow. I'm just playing with the input. Here you can see me try, the minimized test case had 0 edit, but I got so desperate and decided, let's try sudo edit again. The original vulnerability was about, or it's generally about sudo edit, so let's change it to that. But nothing worked. Nothing would, crash sudo anymore. Why? But when nothing seems to have worked while playing around, I eventually took a step back and I did a sanity check. I wanted to see if the argument parsing still works. So I tried to do sudo -l, but I got the password prompt. Yeah, so until when I realized, when I did this basic test, I just wanted to see, can I do just sudo -l, which, you know, the output would then be slightly different, calling sudo -l. But I got the same output as if you just called sudo. And that was weird to me. Like the argument parsing doesn't work at all anymore. This whole passing in arguments in standard input, 0 separated. So this is argument 0, this is argument 1. Passing it in as standard input and then it's internally converted to arguments doesn't work anymore. It worked the whole time for fuzzing. That's how we fuzzed sudo, but now it doesn't work anymore. And it's so, why? But that was a good test because that told me something very fundamental is wrong. It's not about the crash case. It's not that suddenly we don't crash anymore. Something is fundamentally wrong with this setup right now. I would have expected to see this output. Yeah, sudo -l can ask for password though. Yes, but here I'm just showing you. If I just execute sudo -l like this, you should see a different output. So it seems like ASan has changed something important. But also that doesn't make much sense. You see here a typical weird technical issue. Somewhere I must have made a mistake. So I tried to backtrack even more. I wanted to remove the sudo modification that we have done to prepare the fuzzing instrumentation. I want to build a normal sudo with ASan where we can just specify the arguments directly ourselves. In the root folder of the... Yeah, so I figured now something is wrong with the argument parsing, this wrapper that we added to sudo in the main function very early in the series, just to basically now using clean sudo. I just want to use clean sudo but compile it with ASan because we have found out now our test case. We can also do this by hand. We don't need this wrapper anymore. I was just using it because, you know, I modified sudo for fuzzing and I just used the same folder. But I decided, okay, step back, let's use a clean new sudo case again. Docker container, there is an unmodified regular sudo version which I now built with ASan. Alright, let's see. Sudo -l works with that version. That is a good sign. And now we can create a symlink to zeroedit and then try to call zeroedit with the malicious arguments. But now it doesn't crash either. What? Now it doesn't crash either. So this is kind of the same issue here that I'm running into. Or it is the same issue, but it's good that I run into the same issue through a different case. Though it looks so different from the previous issue that I was not sure if it is the same issue. But yeah, the same root issue is causing this whole weirdness. You know, all of these minutes here in the video are basically just wasted. I decided to include this in the video, but it's useless information, you know, to understand the sudo bug. Also, this is unimportant. This is just me failing around with basic Linux stuff, right? But I thought it would be good to include just to show, you know, what kind of weird issues you run into and that you need to push through and you need to stick with it and solve it. But yeah, it's totally wasted time what happened here. What the heck? Quick sanity check. Here is a previous Docker system where sudo edit clearly crashes, and that was built from the same sources, just without ASan. So I got really desperate. This is some really dumb mistake I'm making, and in my desperation I decided to install this ASan. So I don't know why I did this step, but as I said in the video, I was so desperate that I just typed in make install to not call, you know, from the local directory sudo, but now be able to use sudo included in your path. Then you can just type sudo on the command line. You don't need to, just so that sudo is placed into the path that is reachable. And sudo version as the system version with make install. Now I create a symlink from that new ASan sudo version as zeroedit, tried it, and now it works. I create a symlink from this installed sudo now, and it works. Why? Why does it work when I install it, I'm curious. I mean, many of you maybe have already seen the video, but just if you have not seen this video now, do you have any guess what is wrong here? What would you check? Why does it work when the binary is installed, but it doesn't work when I try to call it from within the within the project folder, you know, from the building? Using different config. No, it's the same config. This entirely the same config. The difference is just after the build. So it doesn't, so we config, we make, so it's built. I try it, it doesn't work. I type make install, which moves this binary now into, you know, user local bin. And then I try it from here and then it works. Same build, it's the same build. The difference is just that we make install and it's moved into the path, you know. Install sets the set UID bit. No, all that stuff is taken care. Different user. Yeah, I was switching here the user for tests and so forth, but this is not the impact here. It would have worked with normal. You were calling the install sudo, but this is the newly built one because this has AddressSanitizer enabled. So it is the new sudo version. I'm not accidentally calling the previous sudo version. This is the new sudo version built with ASan, just this time it's working. Yeah, it's linking different libs. That actually would be interesting to check. Maybe, you know, if it links to, I don't know, from current working directory, and now the global one is using global libraries and the other one is using it from its own folder or something. Yeah, that could actually be a good test. I'm not sure if I would have thought about that. Maybe somehow the symlink matters. Yeah, but I did try this with the symlink too. Here in the previous test here, I did the same. I created, see here's the roots. So here's the project, here's source, and here's the output from the build. And I'm symlinking it to 0 edit. So you can see here the symlink to now call it, and it doesn't work. And so here I'm doing exactly the same thing, just with the installed binary. Okay, anyway, yeah, it's super confusing. I kind of stumbled over it by accident, what the solution is. But I actually will mention the solution just a bit later. For now, I'm just happy that it works now. So at this moment, I still cannot explain what the issue is. I just know, thanks to make install, I have now an AddressSanitizer report that I can work with. Okay, so you have to be patient for just a moment to see what the actual issue was. But for now, I'm just happy that it works now. Version with make install. Now I create a symlink from that new ASan sudo version as 0 edit, tried it, and now it worked. AddressSanitizer, heap buffer overflow on address blah blah. I was so confused about this. This dumb mistake killed hours. But eventually I realized my mistake. For no fucking reason, the file source sudo is not the binary. Do you see that? Source sudo is not the binary. Source sudo is a shell script. So I was constantly symlinking the shell script and trying with the shell script instead of the actual binary. But that's made no sense to me, because all the time before, when we were building with AFL and fuzzing with AFL, source sudo was the binary. Why is it now a shell script? Why is source sudo now a shell script? You know, it works. You can call it. So it is, it is not just an empty file or something like this. This is, part of the sudo build. This file makes sense. But why is it there? Why is it now a bash file? And why was it previously a binary? I will understand why in just a moment, but for now, I don't know the reason for it yet, but I now see the problem because now I'm symlinking the shell file and I'm not actually symlinking and calling the binary. And you can see me here doing cut on this bash file, so you can see it here in a moment.
Anymore. Previously, this was the path to the build binary. Now it's a shell script. And the
okay, I'm not. Okay, this is now a bit. Okay, sorry. YouTube is always having, when you pause, you can't see it now. This is bad editing on my side. Usually I should move things up so that when you pause, you can read this. I hope you can still see this. But this bash script here is a comment. Temporary wrapper script for .libs/sudo. So this is a wrapper script calling libs/sudo.
Previously, this was the path to the build binary. Now it's a shell script. And the real sudo binary is in .libs. Are you kidding me? How the fuck did that happen? If we symlink the actual binary in .libs and try it again, now we get...
So, yeah, it was just insane to me. Why was this previously a binary? And now the binary is in .libs. So if I now symlink this path here, as you can see, I'm symlinking source lib sudo to 0edit, and now I call 0edit with -s. Now we get the heap buffer overflow sanitizer report. Now it works. Now the arguments work. Thanks for the Twitch Prime talks. You really helped me calm down from this pain that I had to endure during sudo. Yeah. It's so frustrating. It was so it killed so many hours. So many hours. Just this because and why would I check this? I never came up with this idea to check if this is the binary. It was always the binary. Why would it not be the binary anymore?
The ASan heap overflow detection. I hate computers. Anyway, the overflow...
Okay, I will figure out the reason that was different with the ASan build and the previous builds, why this happened. I actually didn't really look into the source code, like why it happened, but I now understand what build difference I made that caused this. Wait, you were right. I didn't. You said maybe for LD preload because of ASan. Maybe for. Oh, no, it's not. It doesn't really directly have to do with ASan, but it is. It has to do with libraries. Yeah, but it's not inherent to ASan. We can actually change it so that source sudo is the binary again. There's a small mistake I made.
Appears to happen in a...
But anyway, you know, let's just quickly look at this AddressSanitizer report and then I will mention it. This is just the timeline, how it actually happened. You know, I ran into this issue, I failed around. Eventually, I accidentally solved it and I got the AddressSanitizer report. I noticed that the bash file is there instead of the binary. Now I look at the AddressSanitizer report and I look at it, and then after that, I figure out, you know, this issue that caused it.
A function called setCMD, but it only shows us the binary offset in the object file, not the exact source code line. So I thought maybe I need to build sudo.
Yeah, so this was annoying to me. So finally I get the AddressSanitizer output, but I haven't taken the time to look at it yet. And we get the function name, the call stack. This is the call stack where the heap overflow happened. So you see start, then libc start main, and now we call actual main. So this is still, you know, part of libc. And then we call main, yeah, right, it is. And then main calls policy check, then sudo's policy check, sudo policy main, and then set cmd, and in there is something that caused the heap buffer overflow. This is great, but it shows us here offsets in binaries. So you see here shared objects.so and then a binary offset. It doesn't tell us exactly where it is, but we are working here with open source, right? This is the advantage of open source. We should be able to get much better output here. We should be able this to tell us exactly the C file and the line where this error happened. It should exactly give us this information and not this binary information. And I didn't like it. I wanted to have the most comfortable debugging experience for, learning about this vulnerability. So I tried to solve this next.
Offset in the object file, not the exact source code line. So I thought maybe I need to build sudo with the -g compiler option to create a debug build. To do that, I extend the C flags, so the compiler flags.
So this was my first attempt. I did not understand why I would get these binaries and no like file information. So I figured, maybe if I pass -g for debug flag, maybe that would help. Maybe that would give me or add enough information into the binary for ASan to show me the lines.
For the build configuration step, and then build sudo again. Let's see if that helps. Not quite. Let's check.
So still didn't work. Okay. I don't know what the issue is.
Check with GDB. I tried to set a breakpoint to set command and then run it, but it.
So as I said here, then I tried GDB. I wanted to debug this. I wanted to see in GDB, because GDB can also display us the line and the file where it crashes if it's a debug build. And so I tried to set a breakpoint here, but you can already see no symbol in current context. And obviously when I run, then this obviously also doesn't hit this breakpoint. So why does this function not exist, even though we saw it in the call stick?
Doesn't work. And when I looked more closely, I noticed the address range of the function. This looks like a library address. And when we look.
So yeah, then I noticed here these addresses, and as I said, it looks like library addresses. The actual sudo binary addresses are very small here. You can see here 5511D, but these here start with 7FFFF.
Look at the virtual memory map of the sudo process. We can see that this.
Yeah, so what I did now is I open GDB, start the binary, I stop somewhere, and then I look at the memory map of this process, and we can see that these are library addresses. This is not in the binary anymore. This is now an external library. And you can also see here, I just noticed this, I'm not sure if I even noticed this when I did this the first time, that policy check has the information which C file and which line. You can see it here, but the other three functions don't have that. They have the shared object and a binary offset. So yeah, I did notice that this is a library offset and that sudo is loading here some library. And I didn't like this because this makes debugging stuff annoying. I would much rather prefer that sudo is one contained binary, so that I have all the debug information easily available and so forth.
This address must belong to some loaded library. Maybe this libsudo-utils library. So it's probably easier for us to create a build without external libraries, a static build, by having everything in the same binary. That would make debugging and investigating a lot easier. And I think we can do that with the disable shared flag. Maybe you know.
So yeah, I then thought, okay, I want a static build like you are saying. Thanks, 1342, thanks. I wanted a static build without libraries. This was an innocent thought I had. Let's just make it a static build. And I did remember that previously when I built sudo, I used the disabled shared flag. And I actually saw this from the fuzzing project. When I was using this as a reference in an early episode, and here it showed how to build things with disable shared, and I don't know, I just copy and pasted. I didn't really think about this. I just used the same. I also did disable shared. So I remembered this and I thought, oh, I disable shared libraries, so I get a static build. Let's try that. So and in fact I was using this previously in builds before.
Noticed that in previous builds I used that flag. I saw that from the fuzzing project tutorial, and I figured I'd just use it too. When building with ASan, I didn't specify it.
Do you see where this is going? When I built the ASan build, I did not add disable shared.
So adding it again should disable the creation of shared libraries and make this nicer to debug. Let's see. And by the way, that's when I noticed that disable shared flag influences if we get a binary in .libs or if source sudo is already the binary.
When I added this configure flag or compile flag to disable shared libraries to get a static binary again, like I did previously, suddenly source sudo is the binary again. It's not a shell script anymore. I couldn't believe my eyes when I noticed this. But yeah, this was the problem. Was the mistake. I did not properly use the same configure option as I used before. If I had, I would have not ran into this issue at all. I would have not wasted a whole day on this. But yeah, if you create a static build now, this is the binary again. And obviously I noticed this after I compile and I tried to test everything again. Suddenly this binary was not there anymore. .libs sudo, you know, was not there anymore. And I was like really confused. So I checked source sudo and suddenly that was the binary again. I was freaking out. At this moment, I was so annoyed at everything that I thought I'm just canceling the whole project.
So this was the reason why the binary used to be in source sudo and why now the ASan build ended up to be in .libs. This was the small dumb mistake that killed ours. So be careful with those build options. Now we have the new proper build with ASan and disable shared libraries. And when we test the crash, look at that. Now we get the clear information about the file and line where the overflow happened. Thank you, ASan. Let's look at it. Okay.
So finally, 7 minutes in of a 9-minute video, which was just about, you know, setting up ASan, we finally get to ASan. Actually, this video, so there wasn't a plan for this separate episode. This was actually planned to be together with the previous episode. But when I started writing and recording the script, I noticed that it would get too long, but I really wanted to include this fail. If I didn't include this fail, the short ASan part could have been part of the previous video, you know, that would be fine. But I did wanted to talk about this really, really stupid and annoying and confusing error and include that in the series to show you that research and doing this kind of stuff is not like a smooth path. You run into the dumbest and weirdest issues that you need to deal with. And I felt like that's important to include, even though it doesn't really add to the overall understanding of anything. But I hope it shows you that, you know, you need more experience than just exploitation. This is now build tools or, you know, this is now, these issues here are issues because I'm not super experienced with how, you know, configure and all this stuff works. Maybe if I had known this and I had more experience with build what's it called? Build environment? No, build chains, whatever. Then maybe I would have not ran into this issue. But again, through this process, now I gained a lot more experience. Now I know a lot more about configure and make and shared libraries and all this stuff. This is all experience I gained. Anyway, I thought it's important to include. That's why I decided to then separate those episodes and put this into its own episode. Yeah.
At the correct line, we can find a loop that copies bytes around.
Yeah, and now we finally get able to look at the code. So, you know, you can see here now exactly the file and the line where it happens. So let's check. So line, oh no, I don't show the line number, I think. But yeah, so let's look at this code.
The file and line where the overflow happened. Thank you, ASan. Let's look at it. Okay. At the correct line, we can find a loop that copies bytes around. It copies from this from pointer to the location of the to pointer. Also notice here that this loop seems to depend a bit on the check for a backslash. This could explain why the proof of concept crash had a backslash at the end. Now we can start analyzing the bug we found. By the way, in parallel of working through all of this, the AFL++ Fuzzer found apparently 3 more unique vulnerabilities. So let's quickly triage them as well and see what their root cause is.
Okay, so yeah, now we've found this code and we can definitely now look at this code and understand the overflow better. But again, I mentioned this in a previous episode that while I now started to investigate this crash and try to find the root cause that we just did, I obviously had the fuzzer still running, because why not? They just run in the background and maybe they find more. And eventually I noticed that the AFL++ fuzzer found 3 unique crashes. And unique crashes sounds interesting, right? It's just another, are these, I mean, we already found one, so is this 2 new crashes? Did we find maybe crashes in different parts of sudo? Did we find maybe a new 0 day? That's the question.
Vulnerabilities. So let's quickly triage them as well and see what their root cause is. Maybe we did find a 0 day after all. We can use AFL min again to minimize the other crashes. It goes very quick, and then we can look at all the minimized test cases. So this was the original one with the 0 edit and the -s. And now the new crashes. Looks exactly the same. Minimized, they are also just variations of the sudo edit call to -s with a backslash at the end. So they are the same crash, but as explained previously, AFL looks at the executed edges to determine if you reach different functionality, and it's a unique crash because other edges were executed to get here. Anyway, I'm still curious.
Yeah, so as you can see, even though AFL reported them as unique, based on AFL's understanding of uniqueness, they are unique, but when you minimize them, you saw that they are exactly the same trigger, right? It's sudo -s, and then it has a variation length of values there. So they are the same crash, so it's not interesting to us, right? Gamozo shaking, yeah, it's almost Gamozo shaking fist at AFL. Yeah, it's almost embarrassing to make videos about AFL knowing that people like Gamozo exist who are just, on another level. But we lower class people, we are still, working with AFL. Now that might have been insulting to Dominic, but yeah, no, of course AFL is great. Yeah.
At the end. So they are the same crash, but as explained previously, AFL looks at the executed edges to determine if you reach different functionality, and it's a unique crash because other edges were executed to get here. Anyway, I'm still curious if regular AFL will find the bug, and of course if the test cases without specifically mentioning sudo edit will eventually discover it as well.
Yeah, here just updating you again what was happening in parallel. This is explained at length in the previous episodes. I was running a little bit of an experiment. The top 2 fuzzers, so these 2 are regular AFL, and the bottom 2s are the AFL fork called AFL++. Has nothing to do with C++, it's just a fork. They changed the name to AFL++. And so we run regular AFL and AFL++, but both instances also use different initial, what's it called? Initial, they use different conditions. No, not conditions. Oh my gosh, why is my English so bad today? They use different, why can I not remember the word? Different test cases, not seeds. Test corpus, I guess. So you can give it text files that it will use as input, and based on these initial test case input conditions, it will start mutating and try out stuff. And the left ones, the first 2 here, only have basically a file that contains sudo and nothing else. Actually, I maybe have changed it here. It's maybe sudo and a few parameters, -s, -k, whatever. And it doesn't know about sudo edit, while the right 2 fuzzers have a test case with sudo edit. And this is a huge advantage for the right fuzzers because they don't need to discover through bit flipping that this string sudo edit leads to different functionality within sudo. It's probably quite hard for a fuzzer to find a complete string, 4 bytes to match exactly to discover new vulnerability. Eventually they will do this for sure. It's a numbers in a probability game, but yeah, that's why AFL++ found crashes first, and the others took a long time to find that. I wonder how deterministic the mutation algorithm is. This is something Dominic could answer if he is still watching, but my assumption is that it's completely deterministic if you use the same seed. So all the input parameters are the same, like seed, samples. Thank you, samples. Those are the initial like test corpus or whatever. You don't want too much determinism. Okay, oops. Is there determinism if you use the same seed? Like, is the seed basically controlling that it runs deterministically, given that everything else is also, the same? Yeah. And true, what is being said there. Obviously, if you run fuzzers in parallel, you want them to run differently. So you hope that they have at least a different seed, if that's deciding if it's, you can set an actual seed run for the random number generator. Yeah, okay, all right.
Now we can keep the fuzzers running for a few episodes. But what could we do next? We could try and jump right into the exploit development. We have a crash. But maybe it will be too hard to exploit without better understanding the root cause of it. And having a better understanding should make the exploit development much easier.
Yeah, so now here was the question, right? We found a crash and we understand that this is heap buffer overflow. You could basically now go into trying to exploit this. It's pretty clear what kind of exploit primitive you have now, and based on that you can start working on an exploit. But yeah, I had a different plan. I didn't want to go straight to the exploit development.
Also, the original Qualys advisory did explain in some detail why this overflow happened. So I think it would be beneficial for us to come to the same results. How do you figure out this detailed explanation? After all, the theme and the learning methodology of this video series is that we imagine we are the researchers, and we want to create a detailed write-up that explains what causes this crash. And this kind of investigation to explain the root cause is an important skill to learn and practice. So let's do that next.
Yeah, so the original Qualys advisory contained obviously a lot of details. Why, what happened, why is this vulnerable, explaining the code, what leads to that condition. And, it maybe sounds trivial, but when I read an advisory like this before without knowing anything about it, I often ask myself, holy shit, how do they know so many details about this? Like, they know so deep, understand, the code lines to understand this bug. I find this very, very difficult to imagine how a person got to that level of knowledge. I mean, it's clear they obviously spent the time on it and they just looked into it, but how exactly? Like, I want to feel it. Does that make sense? I want to understand on a emotional level, like how that is done, right? Because I haven't really done this for binary stuff on this level before. So I decided, okay, let's actually analyze this code more, and basically with the goal to be able to write a description like this ourselves. So that is going to be the plan for the next videos. I'm not sure, but yeah. Cool. So this was episode 6. Thanks for watching it together with me. I know these videos are very technical and, are obviously not that popular, but they are exactly the type of video I want to make, and I'm happy that there are so many people that still watch this and appreciate this kind of series. So yeah, thanks for hanging out with me and sharing my suffering with this particular issue I ran into this video. Yeah. How many hours in total did the project take? It was over roughly 2 weeks, I would say, and pretty much. So 2 weeks obviously can be 2 weeks as in 5 days, 8-hour work weeks, but it was more like 2 weeks all day. Like I would get up, I would start working on sudo. Obviously, sometimes I maybe would take a break and let the fuzzer run for a bit, but it was basically like 2 weeks for very much full concentrating, including weekends and stuff, working on this. And then, I had to write the scripts. I had to collect more video footage of everything. It's a lot of work. And I'm still working on editing everything. So we are now at episode 6. We are roughly at the half, I think, of the series, I believe. Maybe over it or half, roughly this. So yeah, so exploitation will take a few steps as well. Because sometimes people believe that I'm very experienced in this kind of stuff, that this would like bam, bam, bam be easy for me, but it's not. Like I spent insane amounts of times trying to understand this myself, and I'm sharing with you my process. And I have never exploited something like this before. I have, done dozens of binary exploitation challenges, many dozens of binary exploitation challenges, probably under 100 though. So, I'm not super experienced. It's not something I do every day. So for me, something like this is also a big challenge. This felt like a hard CTF challenge for me, or exploiting it was. So, but I'm even more proud of myself because I knew that this would be a challenge, and I, stuck with it, and I put the time into it and eventually succeeded with my exploit, and that made me very happy. For me, it was almost like solving a CTF challenge, and in the end, I got it, and that made me happy. Ever going to finish the breadboard computer? No, that is the true CTF, truly hardest CTF challenge. Imagine C used length-based strings instead of null terminate by default. Probably 90% of exploits would have been prevented. Yeah, I guess. But a lot of overflows also just happen, when you copy data around, like you receive a network packet. I have a question for you. So you write a protocol in C, and or let's say even in a language where the length field, is where strings have lengths built in, like it's not defined by a null terminating thing. And now you receive a network packet. This network packet has a length field for a string as well as a string with a null byte at the end. So what do you do? Do you trust the length field, or do you trust the null byte at the end? And now you need to deal with that buffer, and they can disagree, and you run into new issues. Serializing data like into a packet or into other serialized formats can also cause issues, because in the end you still operate on like a buffer, right? That you first need to dissect, and then it might not obviously lead to a buffer overflow in that sense, but to other misinterpretation of the data that could lead to issues. Anyway. can you answer question? What are your ways to find use after free bugs in open source code? Is source code review the only way, or are there some automated tools? You ask the wrong person. I have zero experience with that. I guess you can write, I mean, for CTF challenges, I wrote scripts that track, and even for sudo, we will do this in the series. We write scripts to track mallocs and frees to, so you can do that to discover, double frees this way, but also ASan or malloc itself can, in many cases, detect double frees. So, through fuzzing and stuff, you can still find use after freeze. So yeah, I would say probably fuzzing is a good way to find use after freeze. But I don't know, you ask the wrong person, no experience with actual, real software. This was, I think sudo is one of my first, it's probably my first real life software where I wrote my own exploit for like binary exploitation exploit. And actually finish it, not just a crash or anything like this, because I've found some buffer overflow stuff in software before, but I never actually spent the time to build an exploit for it. So this was probably my first time too. Did you use pwn tools in your final script? I believe not. No, I don't think so. Is there a reason why you didn't use ASan while fuzzing? Not really, other than I didn't have the experience fuzzing yet. But throughout doing this and talking to some more fuzzing experienced people, towards the end of the series, I actually experimented more with fuzzing. And in the end, I even ran a bigger fuzzing campaign with lots of different configured fuzzers, where, for example, one fuzzer was or had ASan enabled, but in general, the general premise is to have lots of different fuzzers with different strategies to increase the odds of running into something interesting. So, one of them could be ASan. But yeah, I wasn't really, I think at the time where we are now, timeline-wise, I wasn't sure or didn't know that this is an important strategy to diversify your fuzzing and have a ASan build for fuzzing as well. Sawdust had a class where undergrad students had to find bugs, exploits. Yeah, so that's Pwn College. And I also wanted to look it up because I think they recorded their final presentations where they did go out into real world software and try to find vulnerabilities, and they found it. And I put this on my to watch list because that is also super interesting to me how they did that. I think that shows great success of their Pwn College project. So if you are into or want to get into binary exploitation, it's the videos are not as entertainingly edited like my videos. So they are more like college teaching standard, traditional teaching style, but they are really, really good. Probably contain a lot more information and a lot more experience than my videos. How far in the past is this video? How far in the future are we from this video? Good question. When did I do this? I think the vulnerability came out in February. So maybe I did this in March. Yeah, I think it was March. Ah, cool. Thanks for sharing the presentation. Then I guess here people have it. Okay, cool. Thanks so much again for hanging out with me for this video and asking questions. Now we can move on to other things. Okay, so